Myanmar, a land of breathtaking landscapes and rich culture, is also a place of significant geological activity. Nestled in Southeast Asia, this country is known for its stunning temples, vibrant traditions, and diverse ecosystems. However, beneath its surface lies a dynamic and often volatile geological structure. One of the most prominent features of this region is the Sagaing Fault. This fault line is a major geological structure that plays a crucial role in the tectonic dynamics of the area. It is a significant boundary between the Indian Plate and the Eurasian Plate, making it a key area of study for geologists and seismologists. The Sagaing Fault runs through the heart of Myanmar, extending from north to south. It is a striking feature that can be seen from aerial views, cutting through the landscape like a scar. This fault line is not just a static feature, it is constantly moving and shifting, causing the ground to tremble and reshape. Stretching for over 1,200 kilometers, the Sagaing Fault is one of the longest fault lines in the world. Its length and activity make it a significant geological feature, influencing the topography and seismic activity of the region. The fault slices through the country like a giant crack in the Earth's crust, a visible reminder of the powerful forces at work beneath our feet. This crack is not just a surface feature. It extends deep into the Earth, affecting the geological structure of the entire region. The Sagaing Fault is not just a geological curiosity. It is a dynamic and active fault line that has a profound impact on the region. Scientists and geologists study this fault to understand the complex interactions between tectonic plates and the forces that drive earthquakes. This fault is a powerful force of nature, capable of causing significant earthquakes. These seismic events can have devastating effects on the communities living near the fault line, making it a critical area of study for disaster preparedness and risk mitigation. The Sagaing Fault is one of the most active faults in the world. Its frequent activity provides valuable data for scientists studying earthquake mechanics and tectonic movements. Understanding this fault helps us learn more about the behavior of other active faults around the globe. Over the years, the Sagaing Fault has shaped the region's landscape, creating mountains, valleys, and other geological features. It continues to pose significant earthquake risks, reminding us of the ever-present threat of natural disasters in this region. The importance of the Sagaing Fault extends beyond Myanmar's borders. It is a key area of study for international geologists and seismologists, providing insights into the broader tectonic processes that shape our planet. By studying the Sagaing Fault, scientists gain valuable insights into the workings of our planet. This fault line offers a unique opportunity to observe the interactions between tectonic plates and the forces that drive seismic activity. Geologists conduct field studies and laboratory analyses to understand how tectonic plates interact along the Sagaing Fault. These studies help us learn more about the processes that lead to earthquakes and other geological events. The activity of the Sagaing Fault provides crucial data for understanding earthquake mechanics. By analyzing seismic data and creating computer simulations, scientists can predict the behavior of future earthquakes and develop strategies to mitigate their impact. This knowledge is essential for earthquake preparedness. Communities living near the fault line participate in drills and safety measures to reduce the risks associated with these powerful natural events. Understanding the Sagaing Fault helps us mitigate the risks associated with earthquakes. By studying this fault, we can develop better strategies for emergency response and community rebuilding efforts, ensuring a safer future for those living in this geologically active region.
Subscribe, like, and share Cosmo Academia. To understand the Sagaing Fault, we need to look deep beneath the surface. The Earth's crust, which we live on, is just the tip of the iceberg when it comes to the planet's complex structure. The Earth's outer layer, the lithosphere, is not a single, solid shell. It is composed of the crust and the uppermost part of the mantle, forming a rigid layer that is broken into pieces. Instead, it is broken into several massive pieces called tectonic plates. These plates fit together like a jigsaw puzzle, covering the entire surface of the Earth. These plates are in constant motion, albeit very slowly, moving a few centimeters each year. This movement is driven by forces deep within the Earth, including the heat from the planet's core. Think of them as giant rafts floating on the semi-molten asthenosphere below. The asthenosphere is a highly viscous layer of the mantle that allows the rigid lithosphere to move. The Sagaing Fault marks the boundary between two of these plates, the India Plate and the Sunda Plate. This fault line is a significant geological feature in Southeast Asia. The India Plate, carrying the Indian subcontinent, has been pushing northward for millions of years. This relentless movement has shaped the geography and geology of the region. This northward drift is a result of the process of seafloor spreading, where new oceanic crust is created at mid-ocean ridges and pushes the plates apart. As the India Plate continues its journey, it collides with the Sunda Plate, on which Southeast Asia sits. This collision is not a sudden event, but a gradual process that occurs over millions of years. This collision is a slow-motion crash, building up immense pressure along the fault line. Over time, this pressure can be released in the form of earthquakes, which are common along tectonic boundaries. The release of this built-up pressure can cause significant geological events, such as earthquakes. These events can reshape the landscape, create new geological features, and have profound impacts on human societies. The interaction between tectonic plates is responsible for many of the Earth's most dramatic geological formations, including mountain ranges, ocean trenches, and volcanic activity. Understanding these processes helps us appreciate the dynamic nature of our planet.
The Sagaing Fault, like other faults around the world, is a fracture in the Earth's crust where rocks have moved past each other. These movements are not smooth or gradual. Instead, they are often abrupt and violent, releasing the built-up pressure in the form of seismic waves that shake the ground, what we experience as earthquakes. The point within the Earth where the rock first breaks and releases energy is called the hypocenter or focus. The point directly above it on the surface is the epicenter. The magnitude of an earthquake, measured on the Richter scale, reflects the amount of energy released during the rupture. Not all faults are created equal. They are classified based on the direction of movement along the fracture plane. Understanding these different types helps geologists decipher the forces at play and the potential earthquake hazards they pose.
Section 5 Normal faults pulling apart. When tectonic forces pull the crust apart, it creates what geologists call normal faults. Imagine holding a thick book horizontally and then letting one side drop lower than the other. That's similar to what happens with a normal fault. The block of rock above the fault plane is called the hanging wall, and the block below is the footwall. In a normal fault, the hanging wall moves down relative to the footwall. An example of a region shaped by normal faults is the Basin and Range province in the western United States, where alternating valleys and mountain ranges have formed due to crustal extension. Subscribe, like, and share Cosmo Academia. Section 6. Reverse faults pushing together. Reverse faults, also called thrust faults, form when tectonic forces push the crust together. In this case, the hanging wall moves up relative to the footwall. Think of pushing two stacks of books towards each other. The books in the middle will buckle and some will slide upwards. The Himalayas, the world's highest mountain range, are a spectacular example of reverse faulting. The ongoing collision between the India and Eurasian plates continues to uplift the Himalayas along massive thrust faults.
Section 7. Strike-slip faults, side-by-side motion. Strike-slip faults occur when rocks slide horizontally past each other. Imagine placing your hands flat on a tabletop and moving one hand forward and the other backward. That's the motion along a strike-slip fault. The San Andreas Fault in California is perhaps the most famous example of a strike-slip fault. It marks the boundary between the Pacific Plate and the North American Plate. The 1906 San Francisco earthquake, a devastating event, was caused by movement along this fault. Section 8. Transform faults, connecting the dots. Transform faults are a special type of strike-slip fault that occurs at plate boundaries. They connect segments of mid-ocean ridges, where new oceanic crust is formed. These faults allow the plates to move past each other smoothly. The Mid-Atlantic Ridge, a major undersea mountain range, is segmented by numerous transform faults. These faults are responsible for the jagged, offset appearance of the ridge.
Section 9. Conclusion. Living with the Sagaing Fault. The Sagaing Fault, a colossal strike-slip fault, is a stark reminder of the powerful tectonic forces shaping our planet. Stretching over 1,200 kilometers, it runs through the heart of Myanmar, influencing the lives of millions. This fault line is a testament to the dynamic nature of Earth's crust, where immense geological forces are constantly at play. It is a source of frequent earthquakes, some strong enough to cause significant damage. These seismic events can lead to devastating consequences, including loss of life, destruction of infrastructure, and long-term economic impacts. The people of Myanmar have experienced the wrath of these tremors, and their resilience is a testament to their strength and determination. Understanding how this fault behaves is crucial for the people of Myanmar. Scientists and researchers are constantly studying the fault to predict future earthquakes and mitigate their impact. This knowledge is vital for developing effective disaster preparedness strategies and ensuring the safety of communities living in the fault's vicinity. We need to be prepared for the inevitable tremors. Community drills and educational programs play a significant role in raising awareness and teaching people how to respond during an earthquake. These initiatives help save lives and reduce injuries when the ground starts to shake. Building codes must consider the risk. Engineers and architects are working tirelessly to design and construct buildings that can withstand seismic forces. By incorporating earthquake-resistant features, we can minimize the damage and ensure that structures remain safe during an earthquake. Disaster preparedness plans are essential. Coordinated efforts between government agencies, emergency responders, and local communities are crucial for effective disaster management. These plans include evacuation routes, emergency shelters, and communication strategies to ensure a swift and organized response when an earthquake strikes. The Sagaing Fault is not just a threat, it is also a window into Earth's dynamic processes. By studying this fault, scientists gain valuable insights into the mechanisms driving tectonic movements and the behavior of strike-slip faults. This knowledge extends beyond Myanmar, contributing to our global understanding of earthquake science. Researchers from around the world come to Myanmar to conduct field studies and gather data that can help predict future seismic activity. This research not only helps in understanding the Sagaing Fault, but also provides insights into other similar fault systems worldwide. The data collected from these studies is crucial for developing more accurate earthquake models and improving our ability to forecast seismic events. With better understanding and preparedness, we can reduce the impact of earthquakes on communities. Simulation exercises and training programs for emergency responders ensure that they are ready to act swiftly and efficiently when disaster strikes. Investing in earthquake-resistant infrastructure and community preparedness is essential for minimizing the damage caused by earthquakes. Rebuilding efforts after an earthquake also provide an opportunity to implement better construction practices and enhance the resilience of affected areas. The Sagaing Fault, a powerful force of nature, reminds us of the importance of respecting our planet and its awesome power. It serves as a constant reminder of the need to live in harmony with the Earth's natural processes and to be prepared for the challenges they present. By understanding and respecting these forces, we can build a safer and more resilient future for all. If you enjoyed this journey through the Sagaing Fault, don't forget to subscribe, like, and share Cosmo Academia. Stay tuned for more fascinating insights into our planet's wonders.